All right, let's buckle up, folks. All right, so I think the reason we go through that is, and I could visually see some of the eye rolls in the in the crowd there. What's this have to do with me? But I think it's important to know that what you all do on a daily basis in the summer in New Mexico will translate to other states and other contractors that do chip seal that are wanting to use wrap. And what we learn here from you all is going to get out to other states and probably other countries. And so this is important. So I'm with the National Center for Payment Preservation. I'm part-time with them. Uh, we were established by Michigan State University and an industry group called FP2, which is Foundation for Payment Preservation, to lead collaborative efforts among government, industry, and academia in the advancement of payment preservation. And this started in about 2003. There were some folks in the federal government that knew that even that long ago, they knew that pavement preservation was going to be the key to keeping our nation's road network uh, drivable without spending exorbitant amounts of money, and so that was really a new thought back then. There were folks that were earlier than that starting to think about pavement preservation, but this really kind of got uh, a national group of folks together. And so what we're here at NCPP is we want to advance pavement preservation by improving the practices through education, research, and outreach, which is what we're doing here. And so we collaborate with AASHTO, which is the American Association of State Highway Transportation Officials. So a lot of your folks in the DOT are members of AASHTO. And so through AASHTO, we have what are called preservation management partnerships, which we break up into four regions of the country. And I think 3 years ago, we had our annual meeting for the Rocky Mountain West in Albuquerque. And so New Mexico has been a big part of these preservation management partnerships. And so folks in your area got together and learned about pavement preservation processes and talked about what works and what doesn't work. And that's a really big thing for the DOTs in these areas. We also work through the emulsion task force, which started out working on new specifications for emulsion, but has kind of morphed into all things preservation and recycling, and that's a really good group. We collaborate with, as Joel said, the Road test tracks, the NCAT test tracks in Alabama, and industry. PPRA is the Pavement Preservation Recycling Alliance. We advance preservation. We also do a national pavement preservation conference every 4 years. The next one is in 2027 in Grand Rapids, Michigan in the fall. We work on research projects like this one. We've done a training and education survey, and we've really trying to upgrade our training so that it meets what folks in the industry and in the DOTs need. And then we try and improve pavement preservation. We run the National Pavement Preservation Certification Program. And so we certify contractors, we certify agency inspectors, and we certify agent applicators, just like you all, in chip seal, crack treatments, and microsurfacing. And so we've done that for, I think, since 2014, and we have well over 1,000 certified people in the industry. And so what we try and do with that is a person is certified that they understand how to do a good preservation treatment, whether that's on the inspection side or on the application side. So that's been really fun. I've been a big part of that, and I really enjoy that. And then we do this sort of training quite a bit. So what is pavement preservation? That's what NCPP does, but what is pavement preservation? And so this is a basic government definition of pavement preservation. So we'll read this and then we'll kind of break it down. But programs and activities employing a network level long-term strategy that enhances pavement performance by using an integrated, cost-effective set of practices that extend pavement life, improve safety, and improve motorist satisfaction while saving public tax dollars. Well, that's a lot of words. The treatment that we call a preservation treatment must address pavements while they're still in good condition, reduce aging, extend pavement life, and restore serviceability, make them a better road, make them drain, do whatever they need to do. I'll get on my little soapbox here. What I've learned in the past 4 years with NCPP and going out into the states is that addressing pavements while they're still in good condition. My goal in this industry for the next 3 to 5 years I have left is I want to get people addressing pavements while they're in condition and instead of waiting until, I'm sure you all have had to do a chip seal on a road and you're going, my goodness, this road is way worse than what, a chip seal is not going to fix it. We're going to be back here in 2 years. And I get that states have to do what they have to do because of budgets. But if we could have done the chip seal on that road 7 years earlier, then it truly would have been pavement preservation. So I'm off my soapbox. So let's define that definition. So number one, the New Mexico Department of DOT or any city or township or county, they have a network of pavements. And preservation needs to cover that entire network. And so that's urban pavements, that's rural pavements, that's airports if they control the small airports in their network. It's if you're a city and you have alleys, you have parking lots, that's part of your network, and it for your taxpayers and for to do what you're supposed to do, you need to work it as a network. That's our asphalt, our concrete, and it's even our gravel or dirt roads, which, if I remember right from traveling New Mexico, I think there's actually a few state routes, at least in the about 15 years ago, a couple state routes that were still not paved, which is interesting. It's a long-term strategy. It's got to be a budgeted expense. If we do pavement preservation every year on the right roads, and we keep good roads in good condition, pretty soon after 5, 8, 10 years of doing that, and then we're also fixing the bad roads, but then we're preserving those that we just fixed. Pretty soon as time goes on, there's less and less bad roads that we have to spend a bunch of money on to fix. And so that's why we have to do preservation every year. We need some sort of cycle of touching these pavements continuously. We can't build them and forget them. We'll get to that in a little bit. Integrated department wide. And I think that's really interesting with New Mexico. So you've got the maintenance department and you've got the construction folks, and you all need to be talking because construction can't be doing something that you can't maintain as a maintenance group, or you can't do maintenance processes that screw up what the construction folks do down the line, and then all your stakeholders that you deal with. So it's got to be integrated with everybody. And I think one of the main mantras we have of pavement preservation is right treatment, right road, on the right time. And your wrap chip seals are a great product if it's on the right road at the right time. But sometimes they're not the right product. And so if even though a wrap chip seal done by state forces is a fairly inexpensive process, if we do it at the wrong road or the wrong time, we wasted that money. And so we want to help your DOT understand that when's the best time to do these processes and when do they fit in so they give us the most bang for our buck. And we want to keep the road users happy. Our families drive these roads, our taxpayers do, and it's our job to keep them happy. We like to talk about a preservation mindset. Why do we need that preservation mindset? Well, number one, few agencies can anymore afford a strategy of build it, rehab it, and build it again, which is what we kind of used to do in a lot of parts of the country. It's called the worst first, and we just let our roads deteriorate until the public says that's enough, and then we spend millions of dollars to put it back together again, and then we do that all over. We just let it deteriorate. And so preservation says we're going to inject small amounts of money early and often into that road so that maybe we don't rehab it for 30 or 40 years. And so that's one reason why we do that. Uh, I don't know if you all know, but on your major New Mexico roadways, federal highway has performance thresholds that New Mexico DOT has to meet on rutting, cracking, and ride. And if you're not meeting those performance thresholds, they can withhold money. And I believe, and a lot of us believe, that without pavement preservation, it's going to be very hard to meet to be able to afford to meet those thresholds uh, long term. We've had material changes. Any of you in there in the room that are gray hair like me, you notice that brand new pavements aren't lasting as long. We'll talk a little bit about why here in a minute, but they're just not. Used to be we knew that if we were going to build a new overlay, we'd get 20, 25 years out of that overlay without really having to do much to it. I don't know what you're seeing in New Mexico. When I ask this question around the country, I ask it, so if you did an overlay next week, when do you going to have to do something major to it? And I'm hearing 8 to 12 years. And I don't know if that's about where you all are or not. Some of that's climate specific, some of it's traffic specific. But really, I mean, if we design the road correctly, traffic usually isn't the problem as long as the traffic stayed as we designed for. But it's normally material issues and construction issues. So, and then we have sustainability. We have the Carbon Reduction Act that came in about 5, 6, 8 years ago, and environmental product declarations and things like that. So sustainability is important, and I think it's to say sustainability more a little bit than just the Carbon Reduction Act and saving the trees and saving the environment. But I remember trying to find aggregates, that good quality aggregates in New Mexico, and they could be difficult to find. And so and asphalt cements are not as good as they used to be. And so what we find is that the best materials are already in our roads. And I think New Mexico has done a great job of understanding that, because you all were one of the leaders in cold in place recycling. And I believe you're getting back into cold in place recycling using your wrap chips. You've been doing that. You've been doing wrap cold mix for a long time. And so I think New Mexico really gets that. And, I work with Pennsylvania, and they're starting to figure it out. I mean, they're 30 years behind New Mexico. So anyway, you've got a carbon reduction strategy, and I went through it, and it was kind of disappointing. Is there was no mention of pavement preservation in how to reduce carbon. It was all these little fancy things of electric vehicles and truck parking and all this, and I'm sure it's important, but the biggest thing the department does is build roads, and if we don't have to build roads as often because we're preserving them, I think we're going to reduce a bunch of carbon. So that's me again. The best reason for pavement preservation is it works. This is not AI. This was taken way before we knew what AI was. It's not photoshopped. So the center line of this roadway is the town line between two towns in Connecticut. Uh, Both of these towns went together in 2004, and they did a 2-inch mill and fill on this road. So we can assume that both sides of this road have the same weather conditions. We can assume that they have similar traffic conditions. And from this photo, it looks like traffic probably isn't an issue here. So 6 years later, in 2010, Fairfield, who was one of the early adopters of pavement preservation, came in and said, "Hey, we're gonna do a crack seal, and we're gonna do a microsurface here." And Bridgeport on the left said, "Nah, that's that's crazy. Why would you do that? We don't need to do that." So in another 6 years, or basically at 12 years age of this road, this photo was taken. And if you can see on the left, what's happened to that roadway that was not sealed, it was not preserved. And so the preservation treatment on the right, it kept water out of the cracks that had already started. It kept oxidation from drying out the asphalt. And so you can see that drying, and you guys see it every day. And on your New Mexico roads with the heat and the intense sun, is you see that raveling starting. And that raveling is from the asphalt drying out. And once that little bit of ravel starts, that's when we start getting the cracking. And what happened there in Fairfield is they slowed and stopped a lot of that oxidation from happening. They protected the road surface from moisture. They filled the cracks to keep any other moisture out of them, and they preserved that pavement. Uh, this is just this picture goes all around the world. It is just an amazing story. I will say that Bridgeport on the left is now a adopter of pavement preservation. I don't know what they had to do to this. Their half of the road, I would assume at the least it was a 2-inch mill and fill, and my guess is that wasn't enough. But this is why we do pavement preservation. If you were a taxpayer or you were a road manager, you obviously would want the road on the right, not the road on the left. So why don't we just mill and fill everything? That's easy. Our inspectors know how to do it. Our designers know how to design it. It's a lot easier than pavement preservation. And, it works overlay. The hot mix works by heat. You just heat it up, you cool it down. You don't have all this chemical reaction stuff. Well, we don't do that because we can't afford to. And let me give you 2 examples. And so state example one is what we call a worst first heavy overlay centric DOT. And so they didn't do a lot of pavement preservation over the last 15 years. The interesting thing is earlier than that, they were a big adopter of pavement preservation. And for political reasons, we'll leave it at that, they got away from it. So in 2023, this agency spent 1.6 billion with a B for roadway preservation activities. However, their roadway preservation activities aren't chip seal, crack seal, slurry seal. They are reconstruction, improvements, capital preventive maintenance, which for them is at least 1.5 inches or thicker mill and fill, and freeway and non-freeway resurfacing. So out of their 32, they have a large network, 32,000 lane mile network. At $1.6 billion, they were only able to cover 2,138 lane miles, or about 6% of the network. If you think about it another way, they covered, if they just continue that and they only do 2,100 lane miles of their 32,000 lane mile system, it's going to take them 15 years to get back to doing something to these roads. And we've already determined that for an asphalt pavement, we've only got about 8 to 12 years before we need to do something. So they're already behind the 8 ball. And if you look at it, 1.6 billion divided by those lane miles is about $748,000 per lane mile. Now, I'm pretty sure your wrap chip seal is probably somewhere in the $45,000 to $55,000 a lane mile. So you can definitely tell these guys weren't doing pavement preservation. Now, little story to this. The reason I have this information is I spoke to this state last year, and I had somebody raise their hand. He says, I'm a district engineer from whatever. And I'm going, oh boy, he's going to tell me how wrong I am. He says, last year we touched 1% of our network. We couldn't afford to do more than 1% of our network. So 6% is a 15-year cycle. He's probably on a 2022 year, if not more than that cycle. He says, we're done. We don't know what we're going to do. We have to make a change. So that's what happens if all we do is mill and fill, really. Let's look at another state, different state. These guys, the last one was in lane miles, so 12 foot wide by a mile. This state talks about roadbed miles, so it's a little harder to judge, but they did 7,100 roadbed miles of their 35,000 roadbed mile network. This is a huge state. That 7,100 miles included chip seal, microsurfacing, thin lift overlays, and some hot mix, mill and fill, heavy mill and fill. That's fine. You got to do it sometime. So they were able to touch 20% of their network, which is a 5-year cycle, which is perfect. Their mix of treatments is, they call chip seal coat, 60% seal coat, 20% paving, and 20% other stuff, fog seals, microsurfacings, ultra thin, different other processes. So they're on a 5-year cycle. One of the reasons they can do this, they are just like New Mexico, they self-perform their chip seal. So this state, it's Pennsylvania. Last year, they put down 21 million gallons of asphalt emulsion for their chip seal program, self-done. And I think this year is supposed to be 22 to 23. So a very healthy pavement preservation program, and their roads show it. Yeah, they have bad roads, but they're doing pretty well for what they're doing. So that's why what you guys do every day is important. And so that worst first rehabilitation program won't save your network. And I think New Mexico knows that. However, just like that first state we talked about, states forget it. Sometimes the wrong politician comes in, the wrong people start talking to the wrong politicians, and you can go away from preservation. And I would hate to see that happen. So we need to keep talking about it. Deferring maintenance, letting it go, we'll just wait a couple years. That doesn't save dollars. A balanced approach is best. So when we talk about right treatment, right road at the right time, that can be a problem, especially so even with New Mexico, if all the department was doing was chip seal, which I know they don't. They do microsurfacing. They're doing Cutler, recycle. They're doing thin overlays. They're doing mill and fill. So they're doing a lot of things. But even if all you did was chip seal, which is a great process, and that's all you did, you'd have problems. So we need to have a balanced approach, and we want to plan these lower cost treatments to extend remaining service life. So really quick, and then we'll take a break, is I want to talk to you the difference between preservation versus preservation maintenance. And preservation, to me, is what we don't do enough of as an industry. That is placing a treatment before it looks like you need it, basically. Why are you covering that road? Well, because it's oxidizing as we speak. So preservation is preserving the surface and extending that service life, how long it's going to last. Preservation maintenance is we have some surface defects. We have some raveling. We might have cracking. We might have some rutting, whatever. But we still have a good pavement. And so we need to repair those surface defects while preserving the surface and extending that remaining surface life. Preservation really is time-based. We know that pavement's going to oxidize. Your pavement engineers know how long it's going to take till it starts cracking. None of that should be a surprise to us. And so we need to time those initial preservation treatments to slow that aging. I like to say early and often. Preservation maintenance, obviously there's a time component to it, but there's a condition component, right? You can't fill cracks if there's no cracks. But we want to place as early as possible when defects occur. The best time to fill cracks is when they appear, not when you have miles and miles of cracks that you got to put out a construction project to fill them. We want to add service life with the preservation. We want to stop the deterioration and add service life. Preservation, generally less expensive treatments, and with preservation maintenance, as we move down the curve, they become more aggressive. They become more expensive, but still less expensive than a major rehab or mill and fill. Now, one really important thing is these thin surface treatments, chip seal, microsurfacing, surface recycle, thin overlays, even mill and fills, really, those should not be placed on a pavement with structural defects. And so a structural defect means either the pavement or the base of the pavement has failed. And so pavement failure is, looks like stripping, where the asphalt no longer adheres to the rock and you get below a surface course. If you were to core drill that or, dig it up for patching, you find out that you got an inch of asphalt pavement that you think of, and then everything else is black sand. And that comes from stripping. Water gets in the pavement matrix and it just stops the bond between the asphalt and the aggregate. If we've got a lot of potholes that are getting water down into the base, we've got to repair those. We've got to do really good patches if we've got pavement failure. If we've got rutting that's continuing to rut. Now, if we've got some compaction rutting and right off the bat, we rutted a 1/4 inch and it stopped, then that's really not a structural defect. But if you've got rutting that just ruts and ruts and ruts, you've got a pavement failure. And then heavy longitudinal and transverse cracking. So if you've got that, that means that pavement is almost completely oxidized. It can no longer hold itself together and it's just falling apart in chunks. And so none of these preservation treatments are really good to handle those problems. And then we have base failures with alligator cracking. The base or subbase is failed and no longer supports the traffic load. If you've got water or fines pumping up when it rains, if it rains in New Mexico, the base is failing and alligator cracks will soon appear. So again, if we're doing chip seal on those, we're probably just doing it as a stopgap measure to buy some time. We're not really preserving that pavement. And you know what? We do what we have to do, but we're doing preservation. We're doing maintenance then. We're doing reactive maintenance. Preservation is proactive and maintenance is reactive. So anyway, those are when we should and should not do preservation. You can learn a lot more about this at roadresource.org. This is a free website put together by the emulsion recycling and pavement preservation industries. And if you haven't been on that site and you want to know more about any of this, it's the place to go. And so we also have a chip seal training guide. You can Google NCPP chip seal training guide, or you'll be able to have this presentation and you can use the QR code. But a lot of this is based on this training guide. The FHWA has, I think, 19 different pavement preservation checklists. Here is the chip seal checklist, fog seal checklist. I can't remember if you all are fog sealing after your wrap chip seals or not. Somebody let me know later on. And then also there's a really nice guide that I found when I trained state of Alaska a few months ago. And you can just Google this one, Alaska Surface Treatment Guide. But it's, they're repeat, but everybody uses some different terminology, and this is a great document as well. So with that, we've gone an hour and 15 minutes. Let's take, okay, if I'm calculating time, it's 9:17. Were you all? Can we come back at 9:30? I give you time?
Yeah, that's fine.
Okay. All righty.
So yeah, let's when we come back from break, that was actually a question on my hit list, Rex. So talk about fog seal. So
Okay.
we'll talk
Great.
then.
All right.
Bye.
Great.
Yeah, Rex, this is Joel too. Minnesota has their seal coat handbook, which is probably very similar to these other guides, and we also talk about fog sealing.
Okay.
So that's
Oh,
that's
that's right.
available.
Yeah, that's Tom's book, right?
Yeah, yeah.
Yep.
Tom Wood and Dave Janish was our pavement management engineer.
Yep.
They developed that, and then I updated it here about 5 years ago.
Okay.
So
I'm gonna have to grab that one too. Thank you. I forgot all about that one.
yeah, no worries. All right, see you in a little bit.
Yep. All right, we'll go in about 3 minutes.
Sounds good, Rex. I got to drop off here at about 1:45. I got 11 o'clock meeting that I lead, so
Okay. Well, thank you for joining in and your additions. I appreciate it.
yeah, no, enjoy it. Thanks.
Are you getting any water in the creek, or is it still dry?
No, it's drier than a bone up here.
Wow, we've probably had 7 inches in the last 3 weeks, so I'll send you some.
Yeah. It's been probably 3 weeks since we've really had any measurable precip.
Oh man,
But they're
hopefully that's
talking
at least
maybe Friday we'll get a little bit.
maybe Friday. Hopefully that's hurting the mosquito population though.
Yeah. Well, it's certainly down, but I sat out last night, and right at sunset, you get a couple of irritants come by, but you go in and you come back out in a half hour, you're fine.
Yep. All righty. Well, thank you again.
Yeah, no, great job, thank you.
Okay. I've got 30 minutes after you folks ready to roll. You need a little more time there.
We're ready here.
Perfect. Todd, do you want to talk about fog seal real quick?
Yeah, did Josh, are we gonna fog seal 219? I wasn't clear on that.
Yeah, we typically do. Yeah, that's the plan.
So you typically do fog seal, okay.
Yeah.
Okay, and then later on we can talk materials, what materials we'll be using, but we can keep going with Rex. Anybody got any questions up to this point?
I think we're pretty good.
All right, Rex.
All righty. Hope I'm keeping you all awake. So, project selection and preparation for pavement preservation, and these pretty much is pretty much all the same for every preservation process that we do. Now, I hope that I've got some folks somewhere in the room or listening in that choose your projects. I know for the guys in the field, you just go where they tell you to go and got to do what you got to do. But hopefully, if your folks are thinking about what are we going to do preservation on and what process are we going to choose, first of all, if it is able to be preserved, is the intent preservation? Are we just protecting a fairly new pavement in very good condition to keep it in that condition? That's preservation. Is that our intent? Or is this preservation maintenance where we've got some surface defects that we need to take care of? And again, if we have structural defects, whether in the asphalt layer, what it could be the mid layers, could be the bottom layer, could be just that you've got 22 years of chip seals every 4 years and it's a gooey mess, that's a structural issue. That's the pavement's issue. So if we have those, our preservation isn't really preservation anymore, but that doesn't mean we don't do the treatment. It's just not preservation. So do I have any untreated light to moderate cracking? We're going to talk about cracking and how crack filling, sealing, taking care of these cracks is as we get going. Do I have isolated base repairs I need to think about? And, you know, sometimes when those base repairs get up to be more than 20% of the pavement, it may not be financial feasible to do a preservation. You've got too many structural issues, and you might have to go do something else. Is a chip seal feasible for this location? And you know, a lot of folks, yeah, there's political issues not to do a chip seal. You know, the loose rock, or you turn my black road into a white road, this and that. There's also other reasons. If we have heavy rutting, then a chip seal is probably not. Well, it's not probably. It's not feasible for that location. Very heavy cracking, very heavy oxidation. We're probably okay. So, is a chip seal the right thing for the road? You know, sometimes the night work isn't great for chip seal. High traffic isn't great for chip seal. High speed, and then like I talked, political. If we're doing preservation maintenance, what are the primary and secondary distresses? And so if your designer thinks about that, well, I've got oxidation and early cracking, well, then maybe all we need is a crack treatment and a fog seal, right? Versus rutting and heavy oxidation. Well, that, you know, a microsurfacing might take care of that, or we might have to mill before we do that chip seal. So think about those as a designer. How quickly is the deterioration happening? One of the issues we have with pavement preservation is the fact that preservation occurs fairly rapidly at times. And if a DOT takes 3 years, say, to go from, oh, we need to go crack seal Route 3 to 3 years down the line, the money's there, the project's put out, whether it's internal or external. Well, Route 3 no longer needs a crack seal. It's well past that, and it needs something else. And so we need to understand how quickly this deterioration is happening and plan for that deterioration so we don't come out to try and do a chip seal when really what we need is a mill and fill. Do we have dry and oxidized pavement, or is it flushed and slick? And so that's going to change either what project you select or how you design it. We talked about rutting. So chip seal candidates, very good, is minor cracking, loss of fines, that first start of oxidation and raveling, some flushing. I worry this photo might be a little higher flushing than what we would want to try. Again, not bleeding, but if we've got a little higher asphalt to the surface, we can do a chip seal on that and take care of that surface. Again, oxidation and then loss of friction. A chip seal with good aggregate is going to have good friction and make the road a lot safer. Unacceptable candidates, again, unless we take care of these problems, a rutted pavement is not a good candidate for a chip seal. And I think a lot of chip seal failures that we have anywhere in the country are caused because we've tried to to chip seal a rutted pavement. And if you look at this, if you think about the emulsion shot that you're going to spray on that roadway, and if you think of that emulsion that it has a consistency very similar to water, well, where's that water going? Well, it's going right into the rut. Where is there no water? Up in the high points. Your emulsion is going to try and do the same thing. And we'll talk about ways to mitigate that when we get into best practices, but this is the reason why we don't want a rutted pavement chip sealed. Now, we could go in and mill this, possibly. We could go in and do a rut fill with microsurfacing and then chip it. But if we don't repair those ruts, a chip seal is probably not the best candidate to do that. And again, poor ride. We're doing a thin asphalt membrane with a single layer of rocks. If that's a rough riding road before you start, it's going to be a rough riding road when you're done. We talk about unacceptable untreated cracks over a 1/4 inch, and what we just saying is you do need to treat those cracks that are wider than a 1/4 of an inch, a 1/4 inch and wider. The asphalt cement, the asphalt emulsion will not penetrate and will not fill or seal that crack when they're that wide, unless you're doing a scrub seal and using some other materials. And again, structural issues. That's a little on the wacky side there, but we've got alligator cracking, we've got potholes, we've got all sorts of issues there, and again, you can chip that and it'll be okay for a year or two, but that's not pavement preservation. That's not what we're talking about. Another thing to think about is, so here we've got low severity fatigue cracking in the wheel path, and so that asphalt in the wheel path isn't strong enough to handle the traffic, or it wasn't compacted correctly. And we say this is an unacceptable candidate. And what we really mean by that is chip seal's not going to fix that issue. Again, that's a structural issue. Now it's going to seal that crack. Yes, it's going to do that. It looks to me in the photo that there's some rutting there, so we may not even want to be there in the first place. If it's not rutting, the chip seal, yes, we'll put a Band-Aid on that, but it's not going to fix the problem. It's not that's going to continue to crack. It's going to continue to rut, and it's going to fail. So again, that's not a great candidate for what we're doing. So we talk about preparation in early stage and final stage. And I guess final stage is, that's when your team shows up on the job with the chip spreader, the distributor, ready to go to work. So well before that, we like to see the crack treatments done, if possible, 30 days or more before you start the chip seal. This allows that crack treatment, whatever product it is, to cure. If they gotten a little high, that allows traffic to compact it, knead it down a little bit, make sure it's stuck before we go over with a chip seal. Same thing with our patches. We want to get it patched well out ahead. Any leveling or full depth repairs. You all don't think you have to worry too much about tree trimming, but in some parts of the country, they've got to trim trees before they can get the equipment down the road. So that's part of it. Herbicide treatment, if you've got grass growing, especially if you're going to do shoulders and you've got grass and stuff growing in those cracks, let's treat that and kill it, because that, you've probably seen this, that emulsion acts like a fertilizer, and you're gonna that grass and that crack's going to be happy when you're done. Then we can also do edge milling if we have curb, and micro milling. So those are things that may need to be done depending on the roadway, but they need to be done out around 30 days ahead of when you all show up to do the chip seal. The final stage preparation is obviously the surface cleaning. We're spraying an asphalt liquid, and if there's sand, dirt, mud patties, poop, animal carcasses, whatever, it's not going to stick. Joel mentioned that we did some work in Delaware. The reason we did rut fill with micro is because there was a huge Amish population in the area, and the hooves on the Amish horses pulling the buggies on the shoulders were rutting the pavement. So that contractor had to go out, and they actually, right in front of the microsurfacing paver, had to power wash the asphalt. And then they had this NASCAR-like track blower come right behind and dry off that pavement so they could microsurface over it. So sometimes that's what you got to do, because that micro wasn't going to stick to that horse poop. We've got to cover up our structures, our castings. We may need to remove pavement marking, especially if it's thermoplastic, our buttons, or we have to cover our buttons. Normally, we don't have to worry about paint unless that pavement's been there a long time and we've been painting year after year after year, and we get a really thick buildup of paint, that would need to be removed. Some folks will pre-tack the stripe prior to, even if it's paint, prior to chip seal, and that helps that get a good bond and not have that failure. Protecting our gutters, our railroad crossings, things like that are very important. Crack treatment. I hope the department is sealing cracks before every chip seal process, because we've learned, Adriana's and her team down at NCAT and at Minroad have learned that crack treatments are vitally important for the life of the road and the life of this chip seal. Again, we talk about completing those at least 30 days prior. We don't want a thick overband. The overband, like you see they're putting there with the disc, should be less than 1/8 of an inch. If we're doing mastic, which is a hot applied heavier crack filler that's being used in a lot of parts of the country, and can do very wide cracks or even patches, those need to be flush or slightly below the surface. If we're doing leveling and full depth repairs, again, we want those completed at least 30 days prior. There's a couple reasons for that. Number one, they can, if they're brand new, there can be some off-gassing of some of the light ends coming out, especially if it's a cold mix patch. And so that could cause your chip seal emulsion not to adhere. Also, new hot mix patches tend to really, you would think that they wouldn't because they're brand new, but they tend to be coarse before they've gotten a lot of traffic, and they will suck up a lot of the emulsion. And so if you don't pre-fog those new patches, say, newer than 30 days, newer than 60 days, you can have failures because you don't have a lot of enough asphalt emulsion to hold the chip there. Always, when you're patching, keep them slightly either flush or slightly below the surface. And the ride quality of your leveling and patches must equal the desired ride quality of the finished pavement, because your chip seal is not going to fix a bump. And we talk about that. Chip seal and microsurfacing may level slight depressions, but a bump is always going to be a bump. Folks in like Minnesota DOT does this. Other parts of the country are starting to do micro profile milling, which is, you can see in that photo in the bottom right, the difference. There's a fine milled surface that a lot of states have gone to for everything, but a micro milled surface is a very fine. It does not affect traffic. It does not affect motorcycles. It doesn't affect the application of a preservation product, other than it helps it to adhere better. It gets rid of some of the rutting, gets rid of some of the cracking. And so a lot of states are starting to do that micro mill ahead of a preservation process. Okay, we're finally up to what you guys wanted to talk about, is chip seal. So why chip seal? Well, I'm a microsurfacing slurry seal guy from a long way back. But I have to admit that there is no better preservation treatment than a chip seal. The combination of liquid asphalt sprayed on the road, able to get into the grooves and the oxidized, the crevices, the cracks, gets in there and really waterproofs that pavement, along with a single size chip on top of it to protect that asphalt from wear by traffic, is a fantastic treatment. It does what we need for preservation. It keeps the oxidation from the sun and the water and the chemicals off of that pavement, and it keeps the water off of the top of the pavement and out of any cracks that are in the pavement. So very important tool. Again, it can also be used as an effective form of minor rehabilitation. So it provides a great new wearing course, excellent surface friction, increases our friction numbers up above 40. I like it as that sacrificial wearing course. Traffic and weather hit that chip seal first, and they protect the expensive pavement underneath it. Usually they improve the surface appearance, especially when you're fog sealing after. I'm really glad that you're doing that. Again, remember, chip seal does not add structure. If you've got a bad road before, you're going to have a bad road when you're done. Didn't fix anything. Lipstick on a pig. Again, sometimes we have to do it. I get that. But so again, we kind of talked about that. A chip seal, also called seal coat, really important, is a single layer of asphalt binder, liquid asphalt, that is covered by embedded aggregate, very important, 1 stone thick, whose primary purpose is to seal the fine cracks in an underlying pavement surface and prevent water intrusion into the pavement, into the base, and into the subgrade. The main advantages include improved skid resistance, cost effective. You all, again, especially when the department is self-performing, very cost effective, good durability. Chip seals wear well, have long service lives. We've seen chip seals out there that have lasted 18 years if done well. And pretty easy to do. I mean, yeah, we're spilling oil, we're spilling rock, but if we do it right, it's not that difficult. There's not that much testing, not that much preparation, and so it's just a really good way to maintain our pavements. So everything we're going to talk about best practices for chip seal really holds true for the wrap chip seal that you're doing, except you have some extra steps in the crushing, fractionating, and treatment of your wrap stockpiles. And this one place where I'm hoping to learn from you all, because there's things that I know that I've got some experience in Pennsylvania and some experience in Arizona. You guys might tell me that some things you do that kind of help some of these issues. But for the most part, there's no difference between a chip seal with good solid granite chips versus that of a wrap chip seal, as in best practices. So we're going to talk about that. Why would we use the wrap chip seal? Well, it can be more economical. It's not always more economical. There are some times when the fractionation, the keeping it clean, the keeping it, some cases dry, some cases damp, costs more than it would just to go buy good chips. But there are states and agencies that just like the fact that they're using wrap. This is why you all use it. You have thousands of tons of asphalt milling stockpiled around the state. What else are you going to do with them? Well, I know, like I say, New Mexico does a lot with them. You do cold patch. You have contractors go around and you do it and make wrap cold patch. You put it in your shoulders. You use it. You'll sell it to the cities. You do wrap chip seal, and that's fantastic. A lot of states in the country, especially in urban areas, you know what they do with wrap? They stack it up, and they just keep stacking and keep stacking and keep stacking, and that gets to be a huge issue. A wrap chip seal at times can perform better than a standard chip seal. Sometimes not. Sometimes it does. They seem to be self-healing. They seem to handle traffic pretty well, as long as we get that wrap clean enough to where everything's sticking. It's sustainable, right? We're reusing something that we already paid for, and that's really important for the department. Why not use a wrap chip seal? We're still learning. Again, you all are probably ahead of a lot of the country, but we're still learning about wrap and how it works in emulsion-based systems. And actually, I'm going to back this up, and I think Adriana could probably talk for hours. We're still learning about how wrap works in a hot mix situation, not just an emulsion-based system. So we're all test pilots here, and we're starting to use wrap in microsurfacing. We're starting to do 100% wrap paving. We're doing a lot of things with it, and we just always need to remember that we may be seeing things we've never seen before, and that doesn't mean it's bad. It just means we need to think about it. Again, I've seen it cost more than virgin aggregate due to processing, haul, lack of performance, you know, if wrap's great if it lasts as long as, you know, as the chip that you go buy, but if you only get half the life using wrap, it may not pay. So that's things to think about. Do we really know what's in that huge wrap pile? Hopefully the way you all work, I think you pretty much know where that wrap came from before you start to process this. There's parts in the country that it's just been a dump pile and they try and process it, and that's when we have huge problems. It's sustainable. Again, depends how far you're hauling it, how many times you have to touch it, how easy the rock comes, and how long it lasts. So the $1 million question I like to think about wrap, and I think we've got scientists still studying this, is especially in a chip seal or a microsurfacing, does the embedded asphalt in the wrap release from the aggregate in an ambient temperature system? Are you getting any, are we really getting any bang for that asphalt in the wrap, or are we just getting some black rock? You know, and that's there, you know, there's a couple articles about that in the Asphalt magazine. I know NCAT is studying that. And again, I'm not saying any of this to say don't use wrap in a chip seal. I'm just saying there's things we don't know yet. We really don't know if we use a certain asphalt emulsion, if it will liven up some of that wrap and make it a little more flexible, or is it just a black rock? We're still learning, and it's great. I'm very happy to be in this time where we're learning this stuff. Every best practice that applies to a chip seal applies to a wrap chip seal. Clean stone. Obviously, your stone is wrap, but obviously we can't have too much dust or it's not going to stick. Clean pavement, consistent shot rate, quick application of stone. Don't over apply stone. Roll before the emulsion breaks. 70% stone embedment. And extreme, this is the big change, is extreme stockpile management with wrap. So I guess before I go into the rest of the best practices, Adriana, you were out with those folks on their wrap chip seals. Do you have anything to add about how you were seeing the wrap work in their chip seals as a scientist?
Yes. Can you hear me okay?
Yep.
Okay. So the jobs that we visited were not wrap actually.
Oh, okay. I didn't
We
realize
didn't
that.
get a chance to look at their stockpiles and all of that, but the ones that we went to do our project on were not wrap.
So you're learning too.
Yeah.
Okay. So from the folks in the from New Mexico DOT, what differences? I mean, I'm sure you do some wrap, some virgin chip. What differences do you guys see out there? If any.
The wrap, it has a lot of oil in it, so I mean you use less oil
Mm-hmm.
when you're using wrap. Well, I mean it's good. It's hard on the equipment. The dust when you sweep it and the dust that it makes when you're like on the chip box and stuff like that, it kind of starts sticking to all the hot pulleys and stuff like that.
Okay.
And it works good.
Works good. And so it sounds like that. So it's not really, it's fine particles of asphalt, not really dirt that you're seeing is what's sticking. So it's probably fine particles covered in asphalt, which is what gives it its goody. So, okay. Good. Any other comments or questions on the wrap before we get further down? Okay. All right, and I just always love this photo. So I show this picture on the east part of the country where they have trees and they freak out because they don't see a tree. You guys, this looks like somewhere down around Roswell, so could even be in New Mexico. I don't know, but I think it's Arizona. But anyway, I like this shot. This is what we're talking about. We've got a oil machine here. We've got the distributor. This may be hot applied chip seal. This may not be, might be a rubber chip seal. I don't know. But I mean, we've got that distributor out laying a very beautiful membrane, asphalt membrane. And then we have this chipper or chip box or whatever you all call them, just following right behind, right where it needs to be. If this is hot applied, getting that chip on before that asphalt has time to cool. If it's emulsion, we're getting it on before it has time to start to break. We've got really nice application of chip. We don't have 14 people on the chip box. It's just a well-oiled machine there, and it's a pretty picture. You know, if there's anybody, I don't know if we've got folks that really haven't been out on a chip seal, and so I didn't get a shot of the distributor here. But this is up in Minnesota. This was on Joel's project about this time last year. And so we've got that membrane of oil. We've got some cracks that are probably wider than we would want, but we're doing a good job of spreading that chip there. Another shot from the chip box, how that thing operates. And one more shot here. And again, they're right where they want to be with that distributor. Nice straight line. To me, that's kind of what we're looking for, and whether we're wrap or standard chip seal. Oh, I got one more. I think a lot of people, and I always forget what a ballet it is between the truck drivers and the chipper. And so we've backed up to that truck. This is how they do it. Other folks do it differently. Hooked on. You can see down there's where we've been working back before. You can see the rollers up at the top, right where they should be. And we've gotten going. And so, like I say, there's other ways to hook up. There's other folks do it differently, but that's just to get the get the juices going. So everything we're going to talk about really from now on through best practices always is kind of aimed at getting the correct embedment of the chip into the asphalt membrane. And that's exactly what we're doing here. We are spraying a membrane of asphalt, whether we were using hot asphalt or whether we're using emulsion. And we're going to spread a membrane of a thickness that is designed that when our single chip goes into that membrane, it's going to stick up, and about 70% of that chip is going to be embedded in that membrane once we've rolled it, swept it, and had a few days of traffic on it. So once we've got this, once we're using this chip seal, we'd like to see at least 55 to 70% of that chip embedded in that asphalt membrane. Everything we do for best practices makes sure that we get that embedment of the chip. And we'll talk about it, but I mean, obviously, if we don't have that chip embedded far enough in that asphalt, that chip's going to fall out. It's going to get popped out. Traffic's going to get it, or even it won't even last the brooming and the rolling. So if we don't get it there. On the other hand, if that chip is too far in the asphalt, well, we're going to have flushing or maybe bleeding, or possibly when our rollers, or even when our dump trucks go over it, or our rollers go over it, or our brooms go over it, they're going to pick it up because it's free asphalt getting on their tires. And so that 70% embedment after some traffic is vitally important. And then what we like to say is, while you're doing the process, we need to be making sure that we've got 50 to 55 to 60% embedment before we roll it. Because again, we're not compacting anything when we roll. And so if we're not getting half of that rock embedded in the emulsion right off the bat, then we're not going to make 70% down the line. So embedment is really what we're looking for. I'm happy to say embedment up until now is, there's one or two clunky tests to check for embedment, but pretty much it's the old go ask the old guy. What's that look like? Does that look good? Yeah, that looks good. No, that doesn't look good. Adriana and her team at NCAT are in the process of coming up with a easy, quick test to check embedment. I hope that comes out soon and gets accepted soon. And hopefully the one that they're working on where you get to use just your cell phone camera would be fantastic. So hope you're doing well on that one, Adriana. So what affects embedment? What are the things that you all do out there and your bosses who select the materials? What affects that embedment? Well, that's what we're going to talk about here for the next couple of hours. Yeah, it is exactly 2 hours. So the materials, obviously important. What emulsion we choose, or what hot asphalt we choose, what aggregates we choose, how did we process those aggregates, how did we pick the gradation, things like that are very important to that embedment. The equipment we use, is our distributor working correctly? Is it spraying what we think it should be? Our chip spreader, is it doing what it should be? Are our rollers set up correctly? Are they calibrated? Are they giving us what we need out of that roller? Our brooms, the biggest thing about brooms is do no harm. And so are our brooms set up so that they're not ripping chips out of the mat before we can even open it to traffic? And then our application strategies, timing, things like that. And then of course our existing pavement. And that's part of what we'll talk about is how do we look at our existing pavement and make determinations of, do we need more or less asphalt, and do we need more or less stone? And so all of those come together to affect the embedment. We'll talk a little bit about asphalt emulsions. And before I go, I forgot to ask this. I think I'm pretty sure about this, but are you guys using a CRS 2P? Is that what you're using for your emulsion?
HFE 100P.
Oh, you're doing a high float. Okay.
High float.
I think I've got a slide on that. So good. Okay, that's great. All right. I apologize. I should have got that out earlier. So it doesn't matter. So asphalt emulsion is a chemically stabilized dispersion of fine asphalt particles dispersed through a continuous phase of water as a carrier. Boy, that's a lot of big words. What does that mean? So what that means is we're taking an asphalt cement and we are turning it into a bunch of little particles of asphalt. See all those little dots there? And we're going to coat those with a solution and then add some more water. And the reason we do that is so that those little particles will sit in the tank and bounce around off each other and not come together and make a big ball of goo and be happy. And then we're going to be able to pump those little particles into a tanker, and they're bouncing around and they're going down the road a few hundred miles, 70 mile an hour in that tanker. And they're just happily bouncing apart, happy, happy, happy. You get to the job and it's time to pump it into your distributor, and that goes well. It pumps fine. It goes in, and then you got to pump it again from the distributor to the bar, and then you spray it. And while you're spraying it again, those little particles are happily bouncing off each other. And when it hits the road, those particles have to know, okay, we're time to go to work. We're no longer bouncing around happily. We need to stick together, and we need to stick to the road, and we need to stick to whatever's dropped on top of us. That's what we're doing with an emulsion. And if you think about the chemistry of that and what's going on to allow that to happen, it's pretty amazing stuff. So let's talk about it a little bit. So why emulsify asphalt? Well, the main reason is in order to use asphalt, which is pretty much a liquid rock, or I mean, it goes to a solid if we don't heat it or emulsify it. But we can either use asphalt in road paving by heating it to a certain temperature, 350 degrees, 380 degrees, whatever. And we can heat it. And then when we heat it, we can pump it, we can mix it, we can work with it. Well, that doesn't always work. It's not easy at times. And so we emulsify it so that we add water to it so that we can do those things. We can pump it, we can store it, we can mix it, we can work with it at ambient temperature. That's why we're emulsifying asphalt. So just so you know, if you're not, so asphalt cement can either come from crude oil, so it comes out of the crude slate that's drilled in New Mexico. I just found out the other day that the amount of oil that eastern New Mexico is producing is getting to be almost as much as what Texas is producing. That's amazing to me. Anyway, or it can occur naturally. That there on the left is a lake of asphalt. That's in Trinidad, Tobago, a Caribbean island. And that's just solid asphalt that comes up from the middle of the earth. And when they need some asphalt to go pave with, they take a front end loader or a track excavator, and they grab what they need and they go process it, and the next morning they go drive on it again, just like this. It's really amazing. So again, an emulsion is a homogeneous mixture. That means it's not layered. It's the same. Everything's mixed well. Mixture of two immiscible liquids. That means immiscible means they're not supposed to be mixed. Oil and water don't mix. And we've been able to mix those together, and so that they stay stable. We do that by, like I said, we take that asphalt cement and we put it through a mill, and that mill slices it up into those little tiny particles that we talked about, very small particles. And then at that same time, we inject in water and a soap and maybe some latex or some other chemicals, acids or base to change the pH. And what we're doing is we're grinding up that asphalt into little particles, and then we're coating each asphalt particle with some of this soap solution. And then we're putting it in a storage container. Pretty simple. Again, you can see kind of that little picture there, and then the chemistry. And so if you look here, those little red dots are the emulsifier. And so they've attached themselves to the asphalt particle. In this case, it's a positive cationic emulsion. So that turns that asphalt, gives it a positive charge. Your HFS, we'll talk about in a minute, is not positive, it's negative, but that's okay. Oh, sorry about that. Anyway, an emulsion mill, here's kind of what it looks like. They're very small. It's not a huge deal. A company I used to work for, we had an emulsion plant inside a 40-foot container. Other than tanks, that's all we needed. Here's kind of the mill where they slice that up, and you'll see those teeth on that mill, and that rotor rotates around the stator at sometimes about 12,500 RPM. And so it's just taking that asphalt and breaking it down into really fine particles. And then again, the materials are injected into that mill. We have emulsifiers, the soap, and different additives that go into that emulsion to prevent separation. That gives its curing characteristics, all different things. So we can take different blends of asphalt cement that come out of the ground, and then we can modify those differently with different characteristics. And so that's that repulsion that we're talking about. That's how those little guys bounce around, is because if you remember playing with magnets as a kid, opposites attract and same repel. And so if all of those little particles have a positive or negative. All of them have the same charge. They're just going to, that's how they bounce around in the tank and don't come together. In the case of a cationic emulsion, if you take that piece of rock there, it's pretty much no charge. There's a little positive, a little negative, and you've got that highly positive asphalt particle. And so it's going to be attracted to that rock. And so when you drop that chip into that asphalt, it automatically starts getting attracted, and that asphalt cement moves and grabs onto the rock. I should have flipped this picture over. I need to do that someday. I always forget to do that. Anyway, so that asphalt grabs onto that rock, and then it lets the water go, and you get your break, your set, and your cure of your chip seal. So that's how the emulsion works. Just a second, let me make sure I've got the high float. Darn it, I don't, but I'll walk us through the high float. Okay, so a lot of parts of the country, the chip seal emulsion is a CRS 2P, and a lot of this is the same with your high float. Tell me again your designation of your high float.
HFE 100P.
Okay, so you've changed it. Okay, it's probably an HFRS. It's probably an HFRS 2P. So okay, so CRS 2P. That C means I know the state has its own designation, and but chemically, so this emulsion has a positive charge. It's cationic. Your HF RS, so if this just had RS, then we know that it's anionic. It has a negative charge. And what that means is really important for you distributor operators is if that distributor is spraying your HFRS, and you go spray something else that's a CSS or a CRS, hopefully you need to clean that distributor completely, or you're going to have the positive and the negative of those two emulsions. You're going to end up with a ball of goo in the distributor. So that's why that C is always cationic, is positive. If there's no C, then it's a negative emulsion. The RS is important, and both of your emulsions have this. It's rapid set. And so what that means is when that chip drops into that emulsion, we want that process, that chemical reaction of that emulsion grabbing onto the chip. We want that to happen really quick. And why that's important for a chip seal is you're spraying that chip seal emulsion on a roadway that's got a crown. And if you think about it, you're spraying a liquid that wants to go downhill. That's what liquids do. It acts like water, and left to its own devices, if you just sprayed asphalt or any liquid on that road, it would run to the edge of the road, right? Well, when we spray that liquid membrane, we want it to stay as a membrane. And so let's just say we're at 0.3 gallon per square yard is our application rate. Well, it needs to be 0.3 gallons all the way across that roadway when that chip goes into it. And then once that chip hits it, we need it to start to break immediately, so it's not trying to roll downhill, to roll away, to flow away from that chip. And so we need that rapid set so that we get a really good quick hit of that rock or that emulsion grabbing onto the rock. So RS is important. Emulsions also come in SS slow set, they come in medium set, they come in quick set, but we want this what's called rapid set for a chip seal. 2 means it has a higher viscosity, which is important. So when we talk with an emulsion, a lower viscosity emulsion says it's going to be like water, or maybe even a little less viscous than water, where a 2 higher viscosity emulsion is going to have more, it's going to be thicker than water. And the way they do that is that means there's with a 2, there's more asphalt in the mixture of asphalt and water, but that's an important number. Sometimes we'll have an H, a small h, not the HF. The small h means it's a harder base stock, which is also more viscosity. And the P means we're polymer modified. And we've added a polymer latex, and we'll talk about why in a minute to do that. So that's a standard CRS2P is a standard chip seal emulsion. Your HFRS2P is probably what it would nomenclature out. And that means you've got an RS2P, so an anionic rapid set, higher viscosity, polymer modified, and the high float, and I don't know chemically how they do it, but basically it makes that emulsion form a gel-like coating over that asphalt particle. And that gel-like coating allows that high float to handle higher amounts of dust on the aggregate, which is important where you all are, drier aggregates. So it helps grab onto that aggregate, but because it's an anionic, it often takes a little bit longer for you to be able to sweep it. And so a CRS2P in most parts of the country, they're hard sweeping before they open it in the evening. I'm wondering, do you guys have to wait until the next morning to sweep, or do you still sweep the same day?
No, we sweep the next day.
You see, okay, and that's fine. And that's part of of using that HF is it gives you good things. It allows you to use it with a dirtier aggregate, but it means you can't sweep it really hard until the next day, or sweep it at all till the next day. And it probably stays a little flexible even when you open it to traffic. And it just takes longer. That gel structure takes longer to build strength. It's not bad. It just is. It's a thing that we do in the Southwest because of normally dirtier aggregates. So why do we use the polymer? So polymer coats the asphalt particles while they're in suspension, and it doesn't evaporate away. The polymer does three things. It lowers the temperature at which the asphalt gets brittle when it gets cold. And so certain asphalts start to get brittle and crack at certain temperatures. And let's just say that before we've added polymer to the asphalt, it gets brittle at minus 20 degrees. By adding that polymer, maybe we get to minus 40 degrees or something like that. On the other hand, it raises the temperature at which the asphalt softens. And so if that softening point of that asphalt is 135 degrees before we add latex to it, maybe we get 145 degrees, maybe we get 155 degrees, just depends on the chemistry. And so that gives that asphalt that we're spraying on the road, it gives it a wider range of temperatures that it will perform in. If you think about it, it's a lot like the coolant in your engine, in your truck, in that if you were just using water for coolant, that water would freeze at 32 degrees. That's what water does. And so you would have problems in the winter, but that coolant that you put in, it changes the freezing point of that water so that it doesn't freeze at, whatever, minus 10, minus 30, whatever it's set up as. Also, that same coolant boils at a different temperature. And so instead of boiling at 212 degrees, maybe it won't boil until that engine would get to 250 degrees. And so that if you think about the antifreeze or the coolant in your engine and latex in your emulsion, they kind of do the same thing with temperature. They change the chemical temperature susceptibility of the asphalt or the water. They also add to the strength of the asphalt. They help that aggregate grab on, or that asphalt grab onto the aggregate, makes it a little more flexible, makes it grab on, makes it tougher chip seal. So that's why we're using polymer normally. So again, let's talk about those materials a little more. So we've got our existing asphalt pavement, and we've got that asphalt membrane, whether that we're spraying on, and then we're dropping some uniformly graded chips into it. And this is where using wrap, this is where it's really important that we're getting that wrap fractionated and blended correctly. And so with aggregates, we either have single size aggregates or dense graded aggregates. And what we see in the picture, what we mean by dense graded is we've got little bitty rocks, and we got medium sized rocks, and we got big rocks. And yes, maybe we don't, all of our rocks in this dense grade are smaller than 3/8 inch. So yeah, we've got 3/8 inch chips in there, but we've got number 50, we got number 8s, we've got we got all different sizes. And if you see that, why that's not good in that asphalt membrane is we have little bitty chips that have fallen in that asphalt membrane, and they're completely covered with asphalt. And so they're actually pushing that asphalt up higher on the regular size chips. And then we've got chips that are laying on top of the other chips that aren't embedded at all. And so instead of being embedded 55, 60%, they're embedded 20%. So they're absolutely not going to stick. And then you got everything in between there. And so what we really need to have a good chip seal is a single size aggregate, as close to single size as we can get. And that's one place we kind of get into trouble with wrap is we don't get it to that single size, and we get something going on like that dense graded, and we cause problems with our chip seal. Whether it's a wrap aggregate or whether it's a virgin, we get best performance when we're single sized aggregate. We talked about that as much as possible. We get best performance when we're minimal fines. Now, that changes a little bit with a wrap chip because, like we talked way earlier, is some of those fines are, oh, hang on here. I can only talk so many hours without needing a drink. Diet Coke, by the way. Those fines in a wrap chip, a lot of times they're coated fines, but they can still cause some issues with sticking the big rock into the emulsion. So we got to be careful we don't have too much of it. They do need to be clean. So there's clean fines, which are asphalt coated, or they may be rock fines. We definitely don't want clay fines. We can't have clay or silt in that because that will cause that emulsion to grab onto those clay fines and ball up, and it won't grab onto the big stuff, the rock. We hope that our aggregates, that if we have a 3/8 inch chip, that it is going to be cubical. We don't want elongated chips. And what we mean by that is, so if you crush to 3/8 of an inch, but you have elongated particles, you could have a chip that could fit through a 3/8 inch screen, but it can be 3/4 inches long. And that's not going to work well for a chip seal because that 3/4 inch is going to be different size. It's going to hold up there. It's going to get knocked off with the broom or the roller, and you're going to have an issue. So we really want cubical. That test you may use is flakiness index, may be that test. We also need crushed faces, which I think with a wrap you're probably gonna get, but we don't want rounded river rock in a chip seal. It's just gonna roll around. We're not gonna get any interlocking with those chips. It needs to be abrasion resistance, to be a good surface mix, to be able to keep from degrading once we put it on the road, from degrading when we roll it, and degrading through traffic. The good thing with your wrap is hopefully you're pulling your wrap chip off of wrap surface mixes that have already passed those tests once, And so you know that if it comes off a surface mix on a good highway, you got a good shot that that's going to be a really good chip. They need to be binder compatible. And so you all have found that when we say binder, the emulsion, the best emulsion for you all to use is that high float emulsion, and that's great. There's other places that the CRS emulsion, the cationic, is a better emulsion. And there's other places where that RS emulsion, which is a negative but not high float, is a better emulsion. And so we just need to do some testing to make sure, and you've already done that. Normally aggregate wants to be damp for emulsions, but if we're using hot binders, hot asphalt, it needs to be bone dry so that we don't have any little, we're not making steam or when that wet rock hits that hot asphalt. So those are the best aggregate. Those are the qualities of the asphalt concrete of the chips that we want to make a good chip seal. So wrap preparation and stockpile. Hopefully your folks know where your wraps came from. You're selecting wrap piles that haven't been just trash piles, that have come from hopefully a single source project where the donor road, you knew what it was, you knew you knew what was in there. Watch for dirt, trash. Hopefully the contractors haven't been, or you guys haven't been cleaning out your distributors in it, or putting other junk in that pile, cones, whatever stuff. And then most folks are fractionating or crushing and screening that wrap pretty quickly before it's used on the chip seal. We can't process wrap correctly and then store it for long periods of time without rescreening. When we make that wrap chip, a lot of times we're making a 3/8 inch chip and a type 2 slurry aggregate. Usually that comes off the screen pretty well, or that slurry aggregate might be able to use in your cold mix and stuff like that. We find that we may need to double screen or even light wash to remove coated fines if there's so much fines in there that we're not getting adhesion to the asphalt or to the chip particle. And then I think I teach this stockpile management with regular chips. It's very important to keep the loader off the piles, but I think you've probably found that not compacting those piles once they get out to the job, just probably single dumps, pick them up, put them in the truck, because if you start stacking them and rolling over them, you're going to get a mess. Does that stuff sound like what you're doing now, and any other things that you do with your wrap piles before you take them out onto the road?
No, not really. Pretty much it.
Okay, good. Do you have problems with it sticking in the trucks, or is it crushed and screened fresh enough that it's not doing that?
Yeah, I mean, the one we're using is pretty fresh.
Okay.
Yeah, no problem sticks too much.
All
We don't
right.
have issues with that.
Great. I don't, everybody does it different. This is our yard in Arizona with our crusher screener unit. This one's making slurry aggregate and chip aggregate. You can also blend, and then I think there's actually an even finer set in here that they're taking and they're selling it back to the hot mix people, and they'll put that in their hot mix. So they're using the whole pile. Just a close up. So there are chip seal designs out there and I don't go too deep into them. There's actually 3 different chip seal designs, and what a design means is determining the target emulsion and then the target aggregate application rate. And we're looking at the size of the aggregate, the test results of the aggregate. Is it cubical? Is it not? Is it flat and elongated? Is it not? We're looking at the emulsion. we're looking at the road, we're looking at how dry or how much traffic the road covers, and we put all that into a computer program, and it spits out that we want 0.28 gallons per square yard and 26 pounds per square yard of aggregate or whatever. Okay. And we always need to remember, and we'll talk about this later, but if we're doing a design like that, or we're just using tribal knowledge of what's worked in this district with this chip, with this asphalt emulsion, either way, we always have to remember that this is a starting point, and that the road changes sometimes every quarter mile, and the temperature changes, and the humidity changes, and the traffic in that area changes. And so we need to be flexible. And I think that's one thing that gets difficult for inspectors of chip seal projects to understand is yeah, the plans or the hope is to have a known application rate, but that's going to change as the road changes and the day changes, and the same with the aggregates. So that's kind of why we don't go too deep into chip seal design. Let's see, I think we talked about all this. Yeah, how much emulsion is that road going to kind of soak up? How dry is it? And that just helps us make sure that we get where we're going. Let's see, we've got an hour and a half. We'll go just a little bit. I think we'll go into equipment condition and calibration now. Now we're getting into the best practices stuff. And so asphalt distributor checklist, a nice brand new Bearcat here. Are you guys running Bearcat or Etnar normally? Or do you have a little bit of both?
Oh, it's that iron.
Okay, that's interesting. Most times we get west of the Rockies, it's all Bearcat. And I grew up around Etnar, so I'm happy about that. But and they're all the same. They're made by the same company now. It's just a regional thing. So, okay, great. So, the distributor checklist and anymore, there's there aren't many distributors out there that don't meet all of these requirements, but sometimes a contractor will show up and there's things that aren't working and they need to be working. And so obviously that distributor needs to be computerized. Used to be, we had to go out and we had to nail the speed, know exactly the width, know everything about it, the exact pump pressure, and then hope that we were right. Now with the computers, we got a much better shot at being correct. It needs to be able to circulate between the tank and the bar. Obviously, we need working radar on the Etnar. There are some brands that use that track speed and distance off the differential, I believe, but we need a way to track speed and distance on that distributor. We need a working thermometer. We need to be able to heat without ruining the asphalt. Basically, we need to circulate heat and have soft heat, not direct heat. We need to be able to know how many gallons are in that with a gallon gauge, but more importantly, a calibrated dipstick. We'll talk about that. We need the correct tips or nozzles for application. And I think you all know that well, that different tips and nozzles do different things. We need to make sure that distributor, the strainers are cleaned all the time. Again, that pump is only pumping, and back up, how do I say this? It thinks it may be pumping 300 gallon per minute, but if there's a clog in the strainer, all it knows is how many revolutions it's making and how many nozzles are supposed to be open and all that good stuff. And so it's making a calculation and it's sitting there spinning. Well, if we've got plug strainers, if we've got plug nozzles, if we've got things that are keeping that emulsion from flowing like it's supposed to be, then that computer, it don't matter if we have a computer or not, because it's not going to be right. And if we're not spraying enough emulsion, if we're not spraying what we think, we're going to have embedment issues and we're going to have a failure. So there's things that we could do. And so we need to check the calibration of the distributor to make sure that the computer rate matches what's going on the ground. And so if we say we're pumping 300 gallon per minute or 100 gallon per minute or whatever it is, that's what we're pumping. We also need to make sure that we're getting the right amount of asphalt all the way across the lane width, and you know, because we need a consistent membrane across the lane. We need to make sure we've got enough material to retain the chip and assure we've got a good bond for the paving surface. So that's why calibration is important. So some really basic stuff that we talk about, but we talk about it because we'll come out on a project and see that it's not correct. And so that's why these are called best practices. Number one best practice is those spray nozzles at the same angle. At ours a 30-degree angle. Other distributors have different angles, but we want all, but unless you turn the end nozzle at 90 degrees, we want all of those at the manufacturer's angle of 30 degrees. We do not want variable angles all over the place, because what we're trying to get is a 3 nozzle span. So we want to make sure that each section of that road, except the very ends where we can't do that, obviously, are getting hit with the spray from 3 nozzles. And so on the left there, the green, that's what we're looking for. All consistent spray, you know, everywhere across the bar. If we have different angles on those nozzles, we don't know what we're getting. We've got light application, we've got over applicated, we got okay application all the way across. And so that first thing to check, really easy, is the angle of the nozzles. And you know, your wrench you've got takes care of that. You turn it, you hit the other one, you're at 30 degrees. We're wanting that triple lap coverage. So the next thing to check on that distributor is the height of the spray bar. Is it at the right height to give us that triple lap? And so with nozzles on 4-inch centers, material sprayed from each nozzle overlaps 2 other sprays. Generally, these are designed that plus or minus 12-inch height is where we're going to be. And we say plus or minus because obviously the height of a bar on a fully loaded distributor is going to be different than an almost empty distributor. That difference isn't big enough to matter. But you know, if you are concerned, if you want to check exactly what your distributor, what your height needs to be, the thing is to open every 3rd nozzle. So open a nozzle, close the next 2, open the next, do a test shot, and adjust the height of that bar so that those 2 fans hit at the same time on the road, or you know, at the same place on the road. And so if they overlap, then you know you're too low. If they don't touch, then you know you're too high. And so that's how you understand if your bar height is pretty close. Again, if we don't have the right bar height, if it's too high, we're going to get ridges where we basically got material from 4 nozzles hitting that one section. And if you think about it, that distributor computer doesn't know that you have ridges. So if you have too much asphalt in one location, that automatically means you don't have enough in another location. And so you've got too much in places and not enough in other places. Same thing happens if that bar's too low, and you're going to have gaps that don't have enough emulsion, but you're going to have other gaps that have too much. And so we want to try and get the spray bar about in the median point where it needs to be, so that we're at a triple overlap as much as possible while we're spraying. So we understand that by checking the volume of the tank. Yes, there's a gallon gauge on the side of the tank, but it's usually not accurate enough. And so we want to use a calibrated stab stick to check that. These stab sticks are set up so we drop it down to the level of the asphalt, and then there's a point on the manhole, and each distributor or each model's a little bit different where you mark that, but that will read directly and tell you how many gallons are in that distributor. Needs to be level as much as possible before we do that. And so obviously the way that we make sure that our computer is set right is we do a test shot. And so we get a weight and or volume at the beginning. We shoot 1,000 feet or whatever at 12 foot wide, and we determine what the square yards is. And we, it's very basic. And then we measure the amount on the back end, and we tell ourselves, okay, great. We wanted 0.28 gallon per square yard, and we got 0.275. Let's go to work. We're good. We also, that's the longitudinal rate test, and so that means that bar is reading correctly. But we also have a transverse rate test that says, are we the same all the way across the bar? Because again, we want basically a monolithic asphalt membrane across the roadway, so we get the right embedment all the way across. And so we need to make sure that first set of nozzles is spraying correctly, just like the middle set and the other end set. And so that's the next thing for us to check. Nozzle, depending on the application rate, the viscosity, the pump speed, and hopefully you've either got the slide rule or the Etnauer app that helps you choose the right nozzle. It does make a difference. You also need to be changing nozzles in between a tack job, in between a chip job, in between a fog job, because they can and probably are all different nozzles. We need to think about, I talked about this a little bit earlier, is when we're spraying our application, we need to think about what the road is going to do to us. And so if you think about it, if we have a flushed asphalt surface, if we've already got asphalt sitting on top of that road, then we're probably not going to have any absorption of that asphalt emulsion into the pavement. And so we may be spraying too much asphalt, and we need to look at that. Do we need to reduce our shot rate a little bit? And so that factor here is about take your shot rate times 0.7 if you've got a flushed asphalt surface, and give that a shot and see what that looks like. Or if you've got a very smooth, non-porous surface, then probably that's kind of what the design was for. And so you want to make it about what the design was. If it's more porous, it's more oxidized, you might need to up your shot rate a little bit. And the more porous, the more oxidized, the more cracks. Again, we need to increase that application rate. So that may happen multiple times a day. It might happen a couple times in a lane closure. We've got a lot of patches. We don't have patches. This is newer asphalt. This is older asphalt. That's why it's really important for that supervisor and if you have an inspector to really be driving ahead and looking at the road closely to make sure that the application rate that we're spraying is the right application rate to get that 70% embedment when everything's all said and done and traffic hits the road. So the spreader checklist, a lot easier. I mean, they're computerized as well. They're a little more self-contained. Again, with the reason we have that chip spreader and why we need to go through it is we need uniform aggregate application, because it's got the same type of computer and it only knows what it thinks is being applied. And if the gates aren't correct, if things aren't correct, then it may be applying too much here and not enough on this part of the lane, and you're going to have embedment issues. So again, we need to calibrate that, ensure consistent discharge. We need to make sure the hopper's clean and free of debris and clogs. I think you've seen this with wrap. You can also see it if we've got dirty chip that are too wet. They'll start to clog up in those gates, and the gates either won't close or you don't have as much volume going through the gates as you think. So that's really important. Those hopper gates can come out of adjustment. They all need to be set so that they open at the same time, they close correctly at the same time and at the same amount. No hydraulic leaks, correct tire pressure. We don't want that unit to bounce, things like that. So calibration of the chipper is pretty easy. Your Etnar should have come with some canvas squares that are a known area. I think they're a square yard exactly, but hope so. And so you run your chipper over, you set the computer at what you're chipping, and you measure it with your fish scale. And it's an easiest calibration in the business. And then there are ways to go into the computer to make adjustments. I don't know with the wrap as much, but I tell you that the Etnar guys, when they program those computers and you put in a 3/8 inch chip, and believe me, a 3/8 inch chip is different all around the country, but that chipper is usually right on. There's pretty amazing how they did that. So it is time. I can hear you guys moving around in your seats. Let's take a 15-minute break to, well, I got 12:48, so so 11 o'clock your time. Just a minute or two after 11. Let's come back and we'll get this thing finished up. That okay?
Yep.
All righty. We'll get going in about a minute. Okay, we are just about ready to go. Todd, do you need anything you want to say before I get going?
No, nothing in the chat. Just anybody got any questions? Speak up. All right.
So you all are in for a real treat. I thought I had another meeting at 2 o'clock and I don't anymore, so I can do this all day. What about that? No, I will not subject you to that. So we're going to finish up some best practices and then get on to what's going to happen the day of the demonstration, so to speak. So first of all, haul trucks, and I hope you guys are. I pretty much assume that you're using department trucks all the time, which is really helpful because hopefully they're all set up correctly with. But we need to have our trucks set up with the right chip bar and tailgate latch and the right height, or at least a known height, so that we know our chipper's set up for them. One of the main things I see folks not do is staggering the wheel pass of those chip trucks as they're backing down with the chipper, and especially if we've got any rutting at all, because if we've got some rutting, so we've got a little extra asphalt emulsion down in the bottom of the rut, and then every one of our trucks finds that rut when they're following the distributor, or excuse me, following through with the chipper. We're gonna have some flushing in there, maybe even some bleeding, possibly some pickup. So make sure those trucks are staggering as they back in. Obviously, no sharp turns. If they get crap on the tires, they need to get off without making a mess and get it cleaned up. Obviously, enough trucks to do the job, all sorts of stuff like that. But um, uh, like I say, usually DOTs do a pretty good job of that. It's when we have contractors that go out on the open market and try and rent trucks, and they're all set up differently, and the drivers have no clue. It can be a real goat rodeo on that. So stockpile and loader checklist, and I think this is where we see a lot of issues that contractors and agencies don't think about, and they stem from, we talked about how that chip, whether it's a wrap chip or a virgin chip, needs to be clean, and most of our gradations. So if you have a job with a contractor and they've got a gradation band on that chip, and most of the time the -200 or the dust component is, they're only allowed somewhere between 1 and 2% dust, and I like to see a limit of 1.5 or even 1%, depending on where you are. So that's very clean aggregate, and that's very important. And I tell inspectors especially is it doesn't matter what that gradation was when it left the quarry. If you've got a softer rock that leaves the quarry at 1.5% -200, and it travels 100 miles to the job in the back of the truck, it gets dumped, and then the loader picks up that pile and bucks up that pile and makes a big tall pile and drives up on the pile with the loader, and then reloads the truck, and it gets out to the job. that 1.5% fines might be 2.5%, might be 3%. And so we've really need to make sure where the fines are before we put the rock on the road. But also we need to make sure in the stockpile that we're not doing things to screw ourselves up. And so obviously loader needs to be leak free. We don't need to be dropping diesel or hydraulic fluid on that rock. That's just not going to stick. The stockpile area is clean and stable as possible. Out there, I think a lot of times I've seen you all, well, not with the wrap possibly, but you know, you can get away out there with using the roadside ditch as your stockpiles, as long as you keep up a little bit and don't get any of that silt in the ditch into it. We don't want any free, you know, we want them draining. We don't want water entrapment. But again, that minimal handling to reduce degradation is really important. And so I've seen folks with a really tight spec that they'll have to get a stockpile where their trucks come in. Well, number one, sometimes they just haul out of from the quarry to the job, which is expensive, but in some places it's doable. But if they do have to stockpile, they're just doing single tractor trailer dumps, and they dump it and then they dump tight, and they do not push it up. They don't buck it up with the loader. And then when they go in and haul to the job, then they know that they're getting as close as what that quarry made. What they made at the quarry is what's going to go out to the road, and that's really important. So guys, watch your loader operators that they're not getting down into the dirt, getting into the mud, tracking mud into your chips, whether it's again virgin or wrap. They need to be clean. Roller checklist. This is where we'll get a few arguments. Best practice is 9-wheel pneumatic rollers. I know Cat's got I think a 7-wheel pneumatic roller, and that's fine too. But I mean, the pneumatic rollers designed to have the you know, the flexibility of the pneumatic and the oscillation of those wheels. Minimum 2 rollers, 3 is best. And if you're going to get any, we'll talk a little bit, but if you're going to get any production, all 3 rollers is the best. We are not compacting. We are orienting the aggregate to the flattest side. We're getting a little bit of embedment of that aggregate in the binder. And we are also, by that flexibility of those rollers, we can achieve a mechanical lock of those aggregate particles. Very important. We like to see about an 8-ton minimum on the roller, and more than the weight of the roller is the tire pressure. It's very important. 85 PSI is what normally is design. But what's really more important is that we don't have much more than 5 PSI difference between all the tires. And if you think about it, that road that we're chipping is probably not completely flat, right? We've got a little bit of rutting, we've got some humps, we've got things. And so if we were to use a steel wheel roller on that chip, well, we're going to be bridging over any ruts, any low areas. We're not going to be getting embedment in those areas. And then other areas, we're going to be crushing rock. And so that's important. And then if you think about it, if our tire pressure is all over the board, then we're not going to be putting as much pressure on a section of rock, and we may not be getting enough embedment there by the mechanical lock and the orienting that aggregate. So more than the actual 85 PSI, if we're 80, that's great. Let's be 80 all the way across. Let's be 90 all the way across. But we need to check that. That's important with the rollers.
Rex,
Yes.
if I can interrupt here.
Yeah.
I think it's important to note that New Mexico, at least we observed this and we asked the different districts, they do use the steel roller.
Yeah.
But they use both. So they're using the pneumatic roller and they're using the steel wheel roller. So I don't know if you want to add anything more on that, but
boy, that gets to be
they
an
all seem to
argument
like
when you
it.
get it. Yeah, I know. And maybe your aggregates will handle that. Other places of the country have tried it and have had failures. I think more than crushing aggregate, I'm more worried that you're bridging over a rut and not getting any you're not getting the right embedment in your rut. And so this is one of those things local that some folks do. It was determined not to put it in as best practices, but again, best practices are nationwide, and if it works for the state of New Mexico and it continually works for them, then I'm not going to tell you to stop. I'll just tell you, in most parts of the country, it doesn't work very well. And I look forward to, if you guys use it, I look forward to coming out and seeing the difference.
Yeah, and I'd point out too, remember on this job, especially toward the northern end, we've got some pretty decent rutting.
Yeah. You guys
I think
running
I
the
think-
steel in your district?
Yes, we run 2 pneumatics and the steel wall in the back.
In the back. Okay. Your last roll is with the steel?
Yes, sir.
Okay. That I like that, because hopefully you've already got some embedment. So the first 2, are they making 2 passes each?
Yes, they're making 2 passes each.
And then a third with, okay, I can tell you that if that's the way you're using a steel, that's the best way to do it. Okay, good. I like
and
that.
I'll also add that we had tested a bunch of their aggregate sources, and they all had really good numbers for relay abrasion and all of that. So,
Mhm.
just thought it was important to point that out, because
Well, I
again, that's
appreciate
not
that.
that's not there in the best practices, but certainly something that they do. So,
Yep,
interesting to just see, and they get good results.
absolutely. Absolutely. Good. Any other questions or comments on the rolling? And we get a little bit more on rolling coming up. This is really just the equipment side, not the application side. Okay. Brooms, we like to see self-propelled. I have seen a few tow behind brooms that worked. We like the 4-wheel brooms more than the 3-wheel because they're more stable. Again, with brooming and rolling to some form, the main thing is watch your speed, do no harm. Your job with the brooms, I mean, obviously to clean ahead of the crew, but the job of the brooms is to broom excess aggregate when the binder's cured, and so we don't want to be brooming aggregate that should have been embedded, and we don't want to be dislodging embedded aggregates. So just make sure your brooms are not doing any harm. Water can be used for dust control. We can use a rotary broom, a vacuum broom, a pickup broom, depending on, obviously if you've got curb and gutter or whatever. We found in a lot of places that use all steel bristles that they will dislodge aggregate. So if you're running all steel broom cores, that's something to look for. The plastic seemed to do less damage to the embedded chip, and I think the combo cores I think are fine as well. But 100% metal wire bristles can be problematic. Application strategies, we've talked about the road preparation. We're not going to go back into that anymore. Traffic. Now this is different with your high float emulsion. So, but I'll be interested to see how you handle it. When using a cationic rapid set emulsion, we really like to get, if it's an area where you can put controlled traffic on that chip pretty quick, if we can put 15-mile-an-hour traffic just after the rollers through a pilot car and get some extra embedment on that chip, that really works well. If we can control the speed, if we can control the turning, if we're not running a pilot car, if we've got a 4-lane situation, then we need to keep traffic off until that chip is fully embedded and the emulsion is fully cured. So, and with that high float, depending on how long that remains flexible and how quickly it builds strength, you might need to leave traffic off through your pilot line a little bit longer. So look forward to seeing how that works. I mean, some folks are lucky. Usually DOTs are able to get away with this is they'll just close a 3 mile stretch and do the whole thing and then go down to the next one. So I'm not sure how you all get to do it, but uh, traffic is important because traffic can mess up your embedment pretty bad. If there's a lot of turning, if there's a lot of stopping on the fresh chip, then we need to keep folks off of it as much as possible. So the equipment placement, and I give this to inspectors that have never seen a chip seal job. So pretty basic here. I borrowed this slide from somebody where they call the distributor a spreader truck. Obviously, it's the brooms go first to clean, and then the distributor, followed by the chip spreader, and really important, either roughly 150-foot average distance between the chip spreader and the distributor, or about a minute. And I understand that changes because that distributor will have to back up and pick up a truck and then catch back up. But as much as possible, well, let me back up. We never want to see that distributor go by and then look back and not even be able to see the chipper. We need that chipper as close as possible to that material. Now, with that high float, that may give you a little bit more leeway there, but even so, we have to get that chip on before that emulsion A has time to break, but B has time to go to the low spot, whether that's the edge of the road or the rut or whatever. So that chipper is right behind our chip trucks. And again, we're staggering those chip trucks. We may or may not have a patch crew to make sure that we don't have any humps of aggregate, like where we loaded a truck, or worse, we don't have any open spaces where we didn't, our chip didn't drop and we've got open asphalt sitting on top. And then we got our rollers, and then our brooms come in, whenever that material is ready to broom, which with the HF is a next day thing. So that's our equipment placement. Again, we want to see that chipper and that distributor, like I say, 150 foot, less than a minute apart. We really don't want, where'd he go? I don't know. I can't see him. And then they come up. Air and ambient temperature and best practices is above 55 degrees with no lower than 40 degrees overnight. I know in some of your high altitude areas that above 40 overnight can get tough. We definitely can't have a freeze though. I like to see the air and ambient temperature closer to 60 to 65, especially in the fall. Temperatures in the fall are different than temperatures in the spring. I know that doesn't sound like it makes sense, but if you're in the spring and your road and your air are for the most part continually to warm as that chip seal cures completely, you're going to have a better job than if you're in the fall and the road and the ambient continue to drop while that chip seal tries to cure. So kind of watch that. Dry pavement if possible. If you have heavy rain forecast for the next 24 hours, then it's probably a good thing not to chip. Obviously, if in our part of the country, if we wait till we get a 24-hour forecast without rain, we're not going to chip very often. So that's just something to watch. Kind of like we had last night. They've been predicting for a week that we would have heavy rain yesterday, and through a huge swath of the Midwest. And by God, we had heavy rain. We had 1.5 inches last night. So yesterday afternoon probably would not have been a good day to be chipping, because with that heavy rain we had tonight overnight, you probably would have lost your chips. So pay attention to weather. Emulsion heated to manufacturer's requirements. Usually it'll be 145 is the minimum. Every emulsion's a little bit different, so follow that. But the main thing is we don't want to heat over 185. We can't take the chance of boiling the water out of that emulsion. And so don't always trust those thermometers on those tanks. And so by keeping it 185, you got a pretty good shot of not boiling the water out of that emulsion. Again, aggregate damp for emulsions, but not wet. We don't want water pouring out of the back of the truck. It's good to do tar paper at the beginning and end of shots if you can, to give you a cleaner joint. A lot of folks will leave they'll spray a little bit wider with the distributor than they chip, sometimes 4 inches. I've seen, we did Washington State and they had an 8-inch spec. So that was the most I'd ever seen, but somewhere between 4 and 6, maybe 8 inches is that way. That gives that a cleaner center line with a double shot there. Again, we talked about the chip spreader staying with 150 foot of the distributor. We don't want to go so fast that chip spreader is bouncing. Got some video of a bouncing chip spreader going down, and you can just see that the application rate changes every time it goes up and goes down. So very important. I truly believe in 1,000-foot test strip. Not really even a test strip, because it's even every day that you guys go out is, let's don't let that distributor get a full shot out until we figure out that the chipper's got a problem with the gates and we're not putting our right, let's don't go 3,000 feet with a known issue. And so I think it's a good thing to stop after that first 1,000 foot or so and check your application rate. Check your aggregate application rate, salt and pepper, the embedment. Are we getting a good enough embedment right off the bat that we know we're going to get that 70 at the end? Is our mat good? We have streaks, ridges, humps, pickups, all that. Let's know, because boy, you guys understand this. A chip project moves incredibly fast, and that's a great thing unless you got a problem that you don't catch, and then you get a lot of miles with a problem that's got to get fixed. One of the main things I see wrong with chip seals is over application of the aggregate, too much stone. Ideally, we are putting it down 1 stone thick. Best practice is too much is as bad as not enough. And if you think about it, we got this cute little animation here, and we got our single layer of stone, but then we've actually thrown a few others in. Oh, I hate that. It went too fast. So we've got that one sitting on top, and now we're gonna roll it and broom it. And that top one's not just going to go, it's going to push down on the others, and it's probably going to dislodge 2 or 3 others around it. And so we're going to have a gap, and we're going to have free emulsion sitting up there, because that stone on stone, as we rolled it, the trucks went over it, all that stuff causes a dislodge. And probably all of those stones in that area are probably going to lack a little bit of embedment. We really like to see, of course, when you're using wrap, it's a little bit different color, but we like to see a salt and pepper appearance, which means when that stone is dropped, we want to be able to see some emulsion in between the individual aggregate particles. All we see is heavy rock application. We've got too much application, and we're going to have to work. Well, number one, we're going to have problems with the rollers and things pushing that extra rock in and dislodging the single source. And then we're going to have to work really hard to broom it. We're going to have to absorb probably a bunch of vehicle claims, windshields and paint jobs and all that good stuff. So if you look at this photo here, and if you kind of look at from the lower left to the lower or upper right corner, there's kind of a sweet spot in there where you've got the salt and pepper look, where you can see some emulsion in between the rocks. That lower right corner, obviously that's too much pepper, too much emulsion showing there. And then as we get up towards the top, there's places where there's more chips dropped. But that salt and pepper is really important to be able to see some of the emulsion in between the aggregate. If it looks like a gravel road, you got too much. Here's where our best practice gets in the way of actuality of being able to make money doing a chip seal. The best practice group put together that they wanted a maximum speed of the rollers at 3 miles per hour. And they say that because if you get much faster than that, you can cause chip loss. You'll actually see rooster tails of aggregate dislodged with the roller. But as a contractor, I understand that if we have to hold those rollers at 3 mile an hour, if we want them to roll the material within 2 to 5 minutes of application, that they want that first pass, and we want to roll up and back twice with the pneumatic, and then once with your steel, then 3 miles an hour on those pneumatics, you're never going to keep up. And so, most of these pneumatic rollers have a top speed of about 8 miles per hour. That's definitely your limit. The main thing is, just like the brooms, is if you're seeing aggregate dislodging behind that roller, it's going too fast. Okay. And so just, again, do no harm. Limit your rollers turning and stopping on the fresh seal. The one good thing with your steel wheel roller, I think it's got a top speed of, I don't know, it might have a top speed of 3 miles per hour. So you might be in spec with that. So that might be a good thing. Keeping the tires clean, obviously you all know that. I think that one roller in the foreground there is had some dirty tires over its life, and probably doesn't quite meet what we're talking about. I really believe that your rollers control the speed of the chip seal. And a lot of folks think, well, it's how many distributors I've got or how many trucks I got. But again, that rolling has to be done in a certain amount of time, or it's not going to work. And so you have to have enough rollers, and the rollers need to go at a speed that they can stay close to the chipper and still hit 3 passes, and then get back up with the chipper while that emulsion is still flexible, so that the rolling does some good. So the number and the speed of your rollers will pretty much control, I think, the speed of your chip seal. So we got the roller pattern up and back twice, pretty basic. 3 roller pattern where the 2s just stay back and forth, and that third one can go like that. So brooming should start when the emulsion is cured. Again, this is set up for the CRS, usually between 1 and 2 hours after rolling. Light brooming only. Heavy brooming removes excess chips. Excess chips remove other chips. Embedment is lost. Please remember that. Broom back that center line joint if that's the way, if you keep an open center line joint, and then open to controlled rolling traffic as soon as safely possible. So, just think what you're doing out there. Think about embedment, whether you're a truck driver, whether you're a distributor operator, whether you're a flagger, whatever you do out there. If you're speccing the materials, the embedment is what you're out after. So when that chip has had some traffic to it, you want to make sure that you've got 70% embedment, and hopefully within a year or two, Adriana's going to give you a test method that allows you to do that using the tools that you have in your pickup truck. So that are the final thoughts on chip seal. I do have a few on fog seal. We'll hit those. I'm really glad that you all fog seal the chip. I think that's really good. This kind of goes into fog seal. There's some folks, that fog seal in a dense graded hot mix as a preservation treatment. We're talking more about a chip seal treatment where we're protecting that asphalt from extra oxidation and moisture intrusion. So it's doing just what it does as a preservation. We're just doing an early preservation fog seal. It helps lock in the chips. There's anecdotal evidence that it reduces snowplow damage. There's anecdotal evidence that that dark surface, especially over like a white limestone, helps with snow and ice melt. And obviously that dark surface also highlights traffic markings, and it makes the citizens think they got a nice paved road. Most folks, there's all different types of emulsions that folks fog seal with, CSS1H, SS1H, high float. Not sure if you use or not high float, excuse me. The non-tracking tack, excuse me, is what I meant. Some folks use CQS slurry emulsion to fog seal, and it's really just what works for you. Normally, we're pre-diluting that to about 27 to 35% residual asphalt. So your standard chip seal emulsion is probably going to have about 62, 64% residual asphalt. So we're cutting that at about in half. It's best not to field dilute. It's best to have the manufacturer dilute. It's definitely not good just to drop a hose in the tank and turn it on for a little bit and then drive around the block a couple times and then go fog seal. You have no idea what you're applying. You want to heat that material about 150, 145, 150 prior to application. And again, the distributor best practices are all the same, other than your nozzle is going to be different size. I have heard some folks will maintain the same nozzle size but go every other nozzle. They've worked with that, and that gives them a good application. There's some folks that will have the application rate and drive one direction with half a shot and then turn around and drive half the direction coming back with the other half of the shot. They feel that gives them a better coating on both sides of the aggregate. You know what? It's fog seal. That's all great. If you need a blotter aggregate, a fine aggregate, if you're going through town and pedestrians are going to have to cross, you've got over applied emulsion, you might need some blotter aggregate. Again, the emulsion application rate, this is the diluted emulsion, typically ranges from 0.1 to 0.15 gallon per square yard. But remember, that's at about a 0.27% residual. So you're a quarter of that for the actual asphalt application rate. It's always best to start at the low end of your desired shot rate and work your way up. Don't over apply and then have to work your way down. You'll leave a mess. You might leave a mess if you do that. You want to adjust so you've got a completely coated surface without puddling. So every square millimeter of that aggregate should be coated, but we don't need extra emulsion down in between. I think we have we don't want it to come up more than a third of the exposed aggregate is what we're shooting for. Again, the best practices are about the same. Obviously, sweep the roadway ahead of a fog seal, especially if you're doing hot HMA. Obviously, you've probably swept your chip seal. You've got to cover your manholes. You got to make sure you've got your temporary striping ready to go. Start with that 500-foot test. Check that application rate. Make sure your nozzles are good. Spray bar height is good. You get a good solid application. Usually minimum cure time on a normal day is about 30 minutes, but that might extend to cloudy, high humidity, application rate, all sorts of stuff. But there's a nice looking fog seal. Usually your troubleshooting comes down to bar height, nozzles clogged, or pump pressure, and it really sometimes takes a little bit of adjustment to say, I would always start with nozzles. I would then go to bar height, and if I still have it, then I'd start looking at my pump pressures and things like that. So, questions, comments on chip and fog seal? And okay. All right. Well, let's talk about the PG3 test process that we're doing. And we kind of covered some of this, but again, this is a pooled funds study, and we're trying to help all states learn how to get better at applying payment preservation. So some of the states are picking things that they've never done. Other states are picking things that they do, but they've had issues with. So where they maybe wanted to make specification changes. And so here they can make a spec change, do a test project, and then see how it compares to what they've normally been getting. So we've kind of hit all this. So what we'd like is on your project, there should be a test location figured out ahead of time so that we know when and where to be there. The test section itself is only 500 foot long, but that can be flexible somewhat. And what I mean by that is so like if you've laid out you want your test section here and you've laid it out, well, we really don't want to switch distributors in the middle of that 500-foot section. So we may slide that back and forth because of that, or could be the 500-foot we picked has got some rutting that we didn't think about. So there's nothing hard and fast immediately. The day of the run, we can slide whatever that test strip needs to be, so that we get a good process. So it's important, if we can be there, to have either myself or probably Todd on site the day that you do the test strip. And so we ask that we get about a 14 days notice of anticipated day so we can start preparing. And then we'll get a 5-day schedule review. So we got a better idea when I got to leave. And then we really want a kind of a 48-hour go, no go. And it's kind of helpful to us that test strip, that you don't want to do that on a Monday, just because that makes us travel on Sunday, and my wife doesn't like that. So if we can have a Tuesday is our goal, let's just say of next Tuesday to do your test strip. I think that's a week early, and then the Friday afternoon before that, we get a call that says, yeah, it looks really good. Weather looks good. We're ready. The road's ready. We're going to be there. Or no, we're behind. We're going to be 5 days out. We really like that 48-hour go, no go. Now, if I get there on Tuesday morning and it's raining, or you're broke down, or whatever, that's not a complete disaster. We can wait a day or so, as long as we know it's going to happen. We understand this is construction, and we'll be flexible. But if your emulsion supplier's broke down and you're not going to get emulsion for a week, yeah, I'm going home. But other than that, so again, we don't have to know exactly what day you're going to, you want to start the job on Monday, that's great. Let's just make that the test cell is in the second day's run somewhere. We like if it's weekday daytime hours. We haven't had to worry about that. We'll kind of look at your test cell area just to make sure that, and we've done that. We know there's some rutting in places. When I get out there and I see something that, an excessive amount of oxidation in this place where you want to test, I might suggest that we move it to a different location. What we're really there to do is take a look, get an idea of the equipment. We want to look at the models of the equipment, the types of equipment, does it meet best practice? And all this is going to go into a database. And so a report will come together, and we're going to do multiple chip seal projects, and we'll look at all of them and go, well, 90% of the people had this distributor, this set up this way, but But this group had it set up differently, and actually their chip seal was better. So we need to go look at that. Or we find out that, oh, these people never calibrated their chip spreader and we had a failure. That means we know calibration is vital. That helps us know calibration is vitally important, and we'll put that in the report. So if I'm out there, I'll want access to your equipment in the morning. I just get, I'll just look at the rollers, look at the brooms. We'll take a walk around the chipper. Other than that, once you all get chipping, we are not there to get in your way at all. And we'll be there where the test strip is, and hopefully you're set up so the distributor goes through and the chipper goes through just like it should. We'll stay there and we'll track how long the emulsion was down before the chipper hit it, how long the chips were down before the rollers hit it, how long it took for the rollers to hit it. We'll really take a look at that steel wheel and take some video and some before and after of that. But we're not there to slow you down. We're not there to get in your way. We really won't bother the crew, other than I may ask, I always like talking to the crew, so I may do that. There are, what we need from the agency is we need one person there to help with the record keeping. It is, as part of this project, it is the agency's responsibility to do the record keeping, and our NCPP person is there to help. Todd will get you the data forms. I've got some samples coming up here. We want you to meet whatever best practices and specifications that you have, and hopefully they meet our best practices. And then you all are responsible for field data retention and storage, and the data sharing with the pool study team. And somebody else can talk about that if you have questions on that. So there's 2 forums. Again, our responsibilities are equipment review, material and stockpile review, discussion of best practices with the crew and the inspectors. We'll assist you with data collection, and I'll do a completed after action review of the test cell construction. And we don't have a contractor. You all just are required to provide access to the equipment for me, employees and materials. Again, I do not direct your employees, but I may want to talk to them about, I saw you do this. How come you did that? Well, that's the way I've always done it. Okay. Perform work that meets the project specification and industry best practices, and assist in gathering data. So I might need some help from your distributor operator to tell me, read me off how you got the computer set, stuff like that. We may have some industry volunteers there. I doubt it where this project is, but sometimes we have had folks from FP2 or folks that come in and help take photos and videos, and hopefully they'll go out and review the project after it's complete. I don't have a map of the test cell layout, and I've had a little trouble finding the exact location on a map. So if I could get a little more detailed information sent to me, that would be helpful. I think we're south of 40, south of Santa Rosa. Is that correct?
Yes, and we had selected through Adriana and everything. It's at mile marker 1.2.
Okay.
And that's going to be coming from is that 54? From 54 towards I-40. So that at 54, mile marker 0 starts there, which would be BOP, where the start of the project, and then mile marker 1.2 going north. Going north would be where the test cell starts.
Okay. Boy, I've been down there. There's a whole lot of nothing down there.
Yeah, there's a whole lot of nothing. You get to see the blue hole though.
Oh, okay. All right.
Yeah.
So, boy, there was an old guy down there somewhere that had a roadside stand that made the best jalapeno stuffed olives. I wonder if he's still down there. Anyway, that was a long time ago. He was 90 years old then. The forms, like I say, there's nothing much. A lot of this can be filled out before. We've already talked about it here. The type of binder, If you had a design method, or if it's tribal knowledge, that's fine. Tell us. Any comments? What the planned application rates are for bituminous and aggregate. We have a sheet that asks for any test results that you've done. There's a lot of this LTPP distress stuff that I think Todd and some other folks can help you with. The day of the construction day. Oh, wait a minute. This is still, yeah, there's a little bit of data here, but then we're going to say, I'm going to put down how would you guys do to prepare the surface? Well, we swept it. Okay, great. If you micro milled, if you had to wash it, whatever, we just write that down. Any comments that we have, what the surface, the existing pavement marking, what you did to those pavement markings, if anything. We'll check surface moisture, air and ambient temperature, humidity, all that, just so we get some ideas of what's going on. I'll take note of how many distributors you're using, how many tankers, your support equipment, how many brooms, what kind of brooms, how many rollers, what kind of rollers. I'll take photos of everything. We'll kind of take a look at your distributor and you know, we'll take a look at the nozzle angles and see if they're where they should be. Take a look at that spray bar height. We'll measure it just to see where it is, nozzle spacing, all sorts of things. We'll do the same with the rollers, same with the brooms. We'll try and do this all in the morning before you get going, or at the end of the day when you're all done. So we're not slowing anybody down. Like I say, and then this you can do ahead of time, obviously your aggregate source. So this is wrap. It would be really great if you knew where that, you know, what type, you know, wrap surface mix from I-40 would be great to know on this. Is it pre-coded? Well, yeah, it is kind of pre-coded. What their application rate, just things like that, just little things that we need so we can look at this chip seal and we can look at it in 5 years and it is beautiful. It looks like a brand new road and we can go back and go, well, what'd they do to get that? Versus what happens to somebody else who had a failure in 5 years. So we'll check application rate, emulsion rate on the test cell itself, or as close as we can get. Cure time, when's it open to rolling traffic? When are we gonna broom it? I think in this case, I hope to come back the next morning when we broom. I think I will plan on doing that. I love mornings in the desert, so that's okay. And that's just kind of the things that we're looking for. Again, hopefully your crew knows I'm there because I'm out asking questions, but I don't get in the way. We take some time to get data. There's someone there I can work with to do that. And we'll watch you guys work and have a little fun. And if I can see anything that I think might help you, we'll try it out. And if I can learn anything that'll help somebody else, we'll try that out. So
Yeah,
unless I've got
the
go ahead.
email here ready to go with that form. Josh, I'll send it to you and Gabrielle, and then you guys can call me with any questions, or if we want to jump on a Teams call and go through it. But it's not that intimidating.
No, yeah, that's totally fine. I'll be waiting for it.
Tell me again, what road are we doing?
219.
219.
Yeah, logistically, it's about an hour and a half from Albuquerque, so it's not terrible.
But it's off of 54 heading up to 40.
It's between 40 and 54. Yep. So that looks like about a 15 or 20 mile one way. So are you guys looking to like chip that 1 week and then come back and fog seal it the next week? I know you said you had 2 weeks scheduled for it.
Yeah, we're gonna chip seal it, then fog seal it.
Okay.
And today, what is your best guess?
We're gonna start on the 10th, August 10th.
Okay.
And the test cell will be ready for you on the 11th.
August 11th. Great. All right. So we'll check in with you. I won't book flights yet. but we'll check with you on a couple days ahead of that. And we'll have some fun. Well,
And you
if it's-
guys are still planning on starting at 54 and going north and turn around and come back?
Yes, that's the plan.
Okay.
Sell that first aid.
Josh, when you get, I guess, and it can even be when we're out there building it, we will at some point need coordinates for the test cell. And then the other question I had, were we planning on doing any kind of a control cell, meaning I guess it'd be untreated for this one? We don't have to, but if you were looking to leave anything untreated, we could call that the control cell.
Yeah, we're probably gonna cover everything up.
Okay.
How big of an area? You can
500 feet.
500.
So, I mean, if it would be even feasible at the south end to leave like the first 500 feet from 54 untreated, even just one direction.
We'd prefer to get everything covered up.
I think that's okay. And I know Joel had to jump off, but I don't know that it's imperative that we have any kind of a control. So that's fine.
Yeah, just on our end, it helps avoid all the calls we'll get from the public of why we.
Think so, I'm assuming.
Minimize those claims.
Yeah.
Or supposed claims or whatever may come.
So yes, to the question in the chat, we're going to, I've recorded this,
Yeah,
and so
hopefully
by
so,
the
yeah.
end of the day, we'll have the slides and the recording posted to the PG3 website. So I'll send everyone on the call out a link to that.
Does your chipper have a cab like this one in the photo? You need
No, it
that.
doesn't.
You need one of those.
I know.
That's an interesting story. It's a guy back in New Jersey, works up the Eastern Seaboard, multi-$100 million company, and the owner president is the only one that runs the chip spreader, and that's his office during the day.
Wow.
That's nice.
Yeah.
That'd be nice.
Yeah.
Air conditioned.
Yep. All right. Todd, anything else? Adriana?
Nothing on my end.
Yep,
Thank
we
you,
got through
Rex.
my questions.
Did we get the slides?
Yeah, we'll post them on the PG3 website here later this afternoon. I'll send you guys a link.
Nice, thank you.
All right. Very good. Well, I almost got the full time. You got 8 minutes extra. So talk amongst yourselves and have a great, safe couple of weeks. And I hope to see a lot of you on the 11th and 12th. So y'all take care.
Thank you.
Take care. Thank you.
Bye.
Have a good day.